so I don't forget to do that. All right, let's get going. The first problem that I have is kind of a review of last week, kind of a AP question. I'm not sure what year this was, but let's see how many of these we can answer. It says a particle moves along the x-axis so that its velocity at time t between 0 and 6 is given by the differentiable function v, whose graph is shown above. The velocity at 0 is 0 at time t is equal to 0, t is equal to 3, and t is equal to 5. And the graph has horizontal tangents at t is equal to 1 and t is equal to 4. The areas of the regions bounded by the t-axis. 1 second, I have to sneeze. Well, wait. Sorry about that. And v on the interval 0 to 3, 3 to 5, 5 to 6 are 8, 3, and 2 respectively. So they're telling us that the area here is 8. They're telling us the area here is 3. And they're telling us that the area here is 2. At time t is equal to 0, the particle is at x equals -2. So let's see how many points we can get, because remember, these are AP questions, and there's 9 points total for each AP question. We are trying to get 5 points for each one. If we get 5 points for each one out of 9, we will get a 5 on the AP test. So part A, it says, between 0 and 6, find both the time and the position of the particle when the particle is farthest to the left. Justify your answer. Part B, for how many values of t between 0 and 6 is the particle at -8? Explain your reasoning. Part C, on the interval 2 to 3, is the speed of the particle increasing or decreasing? And part D, during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. All right. Caleb, can you try your mic just to see if it works today?
Yep, it seems, is it working?
All right, I did not see, it didn't look like the mic was even going up and down, which means that I didn't hear a thing. Henry, were you able to hear him? Okay, so that means I can't hear. All right, I'm gonna jump out and jump right back in. As I jump out and jump back in, I want you guys to work on this and see what you get for an answer, okay? Oops. All right, Caleb, let's see if I can hear you this time.
Can you hear me?
I can hear you. Awesome. All right. So, part A, between 0 and 6, find both the time and the position of the particle when the particle is farthest to the left. If I was going to do this problem, first thing I would do is I would make a number line out. Okay, now some people would say, well, this is a number line. Nah, not really, when you think about it. So first thing I did is I said, well, at time t is equal to 0, this particle's at -2. That's what they tell me. And then it's going, ooh, I should have made my, all right, I'm gonna get rid of that there, because I'm looking at what I need to do, and that is not gonna, that number line is definitely not gonna help me. All right, so the first thing I did is I looked at it and I said, okay, at time t is equal to 0, at time t is equal to 0, the value is -2. And then which direction does it go? Okay, so for the next 3 seconds, which direction is this particle moving? All right, sounded like somebody was trying to talk, but I didn't hear anything there. It's going to move to the left, and it's going to move to the left 8 places. So now, at t is equal to 3, this particle's at -10, isn't it? Okay, then it's going to turn around, it's going to go back. It's going to go back 3 places. that's what this means. It's moving back. So now it's at what, -7 at t is equal to, what value is that, 5? It's at -7. And then it's going to turn around and it's going to go back. So it's going to really end up at -9, isn't it? So now I can answer the questions. Between 0 and 6, find both the time and the position of the particle when the particle is farthest to the left. Well, at t is equal to 3, that particle's at -10. And this is good enough work. I mean, if you showed that on your paper, they would accept that as work. Part B, for how many values of t between 0 and 6 is the particle at -8? Okay, what's my answer there? How many times is the particle at 8?
3 times.
3 times. And I can use the same thing right here. Okay, so it's at -8 here, it's at -8 here, it's at -8 here. So at 3 times, it's going to be at -8. On the interval between 2 and 3, okay, so on the interval from 2 to 3, is the speed of the particle increasing or decreasing? Give a reason. Okay, is that particle increasing or decreasing?
The speed
Can
is
you hear me?
Sorry, go ahead, Henry.
All right, can you hear me?
Yep, I definitely can.
Oh, okay. I think it's decreasing because, wait, yeah, well, it's decreasing because it's changing. Yeah, it's decreasing because of the slope.
I'm going to disagree with you.
Sorry, it's
Because what is the slope between 2 and 3? Is that positive or negative slope?
The slope is positive, but since velocity is negative, acceleration and velocity contradict, so speed is decreasing.
But an interval, is the speed of the particle increasing or decreasing? Is the speed of the particle now I'm second guessing myself.
Velocity is increasing, but speed is decreasing, I believe.
yeah. Well, the
Well,
velocity
speed
is technically
isn't speed the absolute value of velocity?
Yes.
yeah, and velocity is technically well, it's technically increasing because it's going from a negative value to a positive value, but it's getting closer to 0. So speed is decreasing because
Okay.
the absolute value of the average velocity is decreasing slowly as you go because it's getting closer and closer to 0. So the speed is decreasing.
These always mess with my mind. All right, because I was thinking acceleration. I must have been thinking acceleration because this is a velocity curve. So if the acceleration would be the slope of it. Okay, never mind. All right. So during what intervals, if any, is the acceleration of the particle negative? Acceleration of the particle negative. All right. So wouldn't that be from 0 to 1? Because now the acceleration would be the slope. So now I'm thinking, okay, so isn't it between 0 and 1? And where else is it? 4 to 6? Am I okay there? On that one? Because if this is a velocity curve, the acceleration should be the slope of it, right? And they're asking us where it's negative. So I'm saying 0 to 1 and 4 to 6. Are you guys okay with that? Speak up now.
Yeah. Yeah.
All right, let's go and see what the answer key says. All right, so in part A, it said, and this is a 3-point question. Therefore, the particle is farthest to the left at time t is equal to 3 when the position is at -10. Got it. Boom. Part B, the particle moves continuously. Let's just go down to the answer. There are 3 values for which t is equal to -8. Boom, got it. So we're already at 6 points. Part C, the speed is decreasing on the interval. Since on the interval, velocity is less than 0. All right, so you guys were absolutely correct. And part D, between 0 and 1, and 4 and 6. So last week, that was part of the assignment, was being able to do particle motion kind of types of problems. Any questions on last week's material?
No, it made sense.
Okay. This week, we're going to be finding area between curves. Fairly easy stuff. I mean, when you think about it, it is, and when you find area between curves, and now you're going to find that this semester, we have about 5 or 6 weeks that are fairly easy from last year, but then we get into polar, we get into vectors, polar coordinates, we get into sequence and series. Ooh, that gets to be some pretty tough stuff. So it starts off easy, it's going to get harder in a hurry. It's hard to say.
Quick question: is
Yep.
most of the stuff this semester new, or it should be relatively new? Because I remember doing series, and
You did series already?
I did series last year. Yeah,
Oh,
I
now
hated it.
did you do
It's-
divergent
Yep,
and
divergent,
convergent?
convergent series, like the series formula, figuring out which series is which. Like I'm not gonna
Wow.
remember any of the names, but I hated it.
Taylor
Yep,
series,
Taylor
McLaurin
series.
series.
Yep.
That is BC calculus. That is the majority of BC calculus. If you've had it already, whoa, you're way ahead, because that is the new stuff in BC Calc. So if you've seen it already, I don't know who your teacher was last year, but whew, you definitely went farther than you should have in AB calculus, because BC calculus is the one that covers sequence and series and all that. So you're ahead. Maybe you can help me, because man, there's some problems that I look at with convergent and divergent, and whew, just blows my mind away sometimes. All right. So this week we're going to be talking about area between curves. The formula is fairly easy. If f and g are continuous functions, and f of x is greater than g of x through a and b, then the area between the curves is just going to be the integral from a to b of f of x minus g of x. And you can, I always, and you guys are BC calculus, so this is probably too easy for you guys. When I start doing area between curves with my AB calculus kids, I always start off with something that's fairly easy. You do something like y is equal to let's say 2, and y is equal to 5. Well, if I want, let's say I want to find the integral from 0 to 6 of the area between these two curves. Well, that's easy. I can graph that out. I can figure that out without doing much work, because y is equal to 2 is just a horizontal line. Y is equal to 5 is a horizontal line. If I'm going from 0 to 6, that's pretty easy. I can do this algebraically. I can just figure out the area between there. What is that? That's the height of 3. So my answer would be 18, wouldn't it? So my answer would be 18. But if I was using calculus, I can still find that. So I have the area, or the integral, from 0 to 6. My top function would be 5, minus my bottom function, which is 2 dx. And then I would take the integral of this. Well, the integral of 5 is just 5x, minus the integral of 2 is just 2x. And that is from 0 to 6. So now I plug 6 in here. 5 times 6 is 30, minus 2 times 6, which is 12, minus, and then I put 0 in here. 0, that's just going to be 0, right? So 30 minus 12, lo and behold, that's 18. So I can show my AB calculus kids, hey, top function minus bottom function on the interval, that is how you find the area between two curves. And then we can show it using calculus to figure that out. That's all it is. Top function minus bottom function on the integral. All right. So, and this is kind of, this is the way the book shows it, and they put all this goofy figures in there. Top function minus bottom function. That's it. So if I wanted to do a problem, this is a problem off an AP test. It says, let R be the region in the first quadrant bounded by the graph y is equal to 2 to the square root of x. Okay, so this is y is equal to 2 to the square root of x. and the horizontal line y is equal to 6. And the y-axis, as shown in the figure above. Find the area of R. All right, well, I'm looking at this problem, and it's like, okay, my top function is 6. My bottom function is 2, the square root of x. So I'm going to go the integral from 0 to 9, because it's on the x-axis. If I was working on the y-axis, if I was, and usually we do this when we rotate things, then you go on the y-axis for your intervals, but this is 0 to 9. And then I have just 6 minus 2, the square root of x. Now, here's where, do you know how to take an integral or not? Some of you already know how to plug it into your calculator and get the answer. I want to see some work. That's just my little thing. So I would rewrite this as 2x to the 1/2, and then we take the integral. And I'm going to let you guys find the integral of this. I want you to tell me what the answer is, okay? Without a calculator, please. All right, and when you get an answer, please put it in the chat box or just say it on, give us the answer. All right. I know both of you are probably saying, no, I have to do it by hand. And that's, on the AP test, that's where they get you. I mean, they'll get you where, they'll give you a problem like this and it's non-calculator, so you really have to know how to take the integrals. I mean, they don't give you any really difficult problems, but they will, this one is, you should be able to take the integral there and find the value of that.
Is that x to the 1/2 in the second equation?
Yes, because I had 2 the square root of x, so I just rewrote it as x to the 1/2.
Oh, right. Okay. So, yep. Okay. Sounds good.
And I'm gonna work it out over here. Integral of, so that's going to be 6x minus, well, the integral of this, we're going to add 1, so that's going to be 2x to the 3/2 over 3/2, which is really times 2/3. So this is going to be 6x minus 4x to the 3/2 over 3. Now this is where I'm going from 0 to 9. This is where you're being able to find x to the 3/2 is going to come in real handy. So what is this going to be? 54 minus, well, 9 to the 3/2, is that 27? And then 27 times 4 divided by 3, so I can just simplify. So that's 36, I believe. So 54 minus 36 is going to be 18. And then if I plug 0 in there, that's just going to be 0, right? Is my answer 18? Oh, Henry got 18 too. Bingo. That's, yeah. So do you see how many things they're testing you on the AP tests here? When you think about it, I mean, how many kids know that if you plug 9 in here, 9 to the 3/2, how many kids know that that's 27? But you better, because, this is the root. So the square root of 9 is 3, and this is the power. So 3 to the 3rd power is 27. You got to know that stuff. They're testing you on more than calculus on these AP tests. All right. And the answer is 18. Woo-woo! Got it. Let's see here. Caleb, did you get 18?
Yes, I did. I went too far though, and then subtracted that from the y equals 6 thing because I forgot to add in the 6 originally.
Okay. Don't want to go too far. All right. This problem here, is this the one that's a little bit tougher? Yeah. No, this one isn't that bad. There's one that's a little bit tougher here. It says, in the figure above, now this is a calculator problem. Okay, you usually can tell calculator problems from non-calculator problems because they put in 4 natural log of 3 minus x. You're not doing that without a calculator. So let's set it up and let's see if you guys can find the answer using your calculator. It says in the figure above, R is shaded region in the first quadrant bounded by the graph of 4 natural log of 3 minus x. So I'm going to say that this is 4 natural log of 3 minus x. Horizontal line y is equal to 6. So this is y is equal to 6 here, this line. And the vertical line x equals 2. Okay, so now they gave us our interval. Find the area of R. Well, if I'm going to find the area of R, I'm going from 0 to 2. First thing I do is I always find my interval. And then top function, which is just 6, minus the bottom function, 4 natural log of 3 minus x. Okay, now this is where a calculator comes in handy. Do both of you guys have a graphics calculator? All right, Henry, you too? Okay, do you guys know how to use your graphics calculator to find an integral? All right, so what is my answer here? What is the integral from 0 to 6, or I'm sorry, 0 to 2 of 6 minus 4 natural log of 3 minus x? 6.82? I don't know, I don't have my graphics calculator here. Henry, did you get the same answer? Haven't plugged it in yet. Okay, so we're just gonna say that it's 6 point. Now, if I was going to just estimate the answer, this is kind of looks like it's about a little bit more than half of this rectangle. Well, this is 2 times 6, so that's 12. It's definitely more than half. So an answer of 6.82, that to me sounds about right. I mean, just eyeballing the answer up, 6.82 looks like it's in the ballpark. Right? I don't know if I have the answer key here. Oh, I do. 6.817. So we do have the answer, and it is correct. This is a tough problem. This is probably one of the hardest AP questions that I've seen using area in a long time. I don't even remember what year this was, but man, I am telling you, there are not a lot of students that get this problem right. It says, let R be in the region bounded by, and this goofy graph is y is equal to e to the 2x minus x squared. So obviously this is a graphics calculator type problem, okay? Whenever I have a problem that is a graphics calculator type problem, I plug it into my calculator and I make sure that I can graph it out so it looks exactly like this. So if I'm, my windows, do you guys know how to change your windows? Because on my X, I would go from 0, I might go from -1. I might go from -1 to 4 on the x-axis, just a little bit bigger, and from 0 to maybe 3 on the y-axis. So I get a picture that looks very similar to the one that's given, because when they make these problems, they look exactly the way they're supposed to. So if you graph this out, you should get the exact graph. It should look exactly the same. So now, and the horizontal line y is equal to 2. So this is y is equal to 2 here. It says find the area of R. Okay, so I need to find the area of R. And I need to find the area of S. Okay, so let's not do S yet. Let's do R. R is a pretty easy problem. That's not bad. I mean, top function. So I've got the integral. Ooh, I need these points. So now they're testing you to see if you understand how to find points of intersection. So the first thing I would do is I'd plug this into y1. I would plug y is equal to 2 into y2, and then I'd find my points of intersection. Can you guys tell me what these points are? What is this point here? What is this point? Because that is going to be my integral. Okay, that's going to be my interval that I need to find the area of R. Because top function to find the area of R is just going to be e to the 2x minus x squared minus 2. But I need my interval. And in order to find my interval, I need these 2 points.
They're both very long decimals.
Just give me 2 decimal places.
All right, 0.45
Okay?
and 1.55.
All right. So now I should be able to find the area of R, right? Boom. Plug that into my calculator. What's my area of R?
Just a sec, I gotta put that in.
Okay? Be very careful, because when you put in exponents that are longer than one thing, I always make sure I put it inside parentheses just to be on the safe side. Henry, you following along here? I don't want to lose you.
Okay, I got 2.71.
All right, 2.71. All right, now that wasn't that bad, right? As long as we could find the points of intersection there, wasn't too bad. However, this is the one that most kids could not figure out. How to find the area of S. Okay? So what I'm going to do is I'm going to let you guys work for a little bit, and I want to see what you get for an answer there. Okay? Find the value of S. Let's see what you get. Turn off my mic and let you work. Right. Any answers yet? You're getting a negative number. Yeah, I am going to say that area is always going to be positive. Okay. Now, if I was going to do this problem, this is what I would do. I'm looking at this problem, and I'm looking, and it's like, okay, how am I going to get just this piece here? Well, what if I found this whole thing? Because I can find that. That's not a problem. I could just take the integral from 0, because this looks like it's at 0, and I don't know what this point is here. It looks very close to 2, so I'm just going to say 2, of e, the top function is e to the 2x minus x squared minus the bottom function, which is just 1. If I find that value, that is all of the green. So if I just subtract 2.71 off, because that's what we came up with this
I
top
did
part.
that integral and I got, oh yeah, I see where I went wrong. Okay, yeah.
And then all you have to do is subtract 2.71 off of there, and you should get the middle portion of that. It was a pretty complicated problem, I have to say. I mean, so many students, this problem, when I was still teaching face-to-face, kids did not get it. All right, let me see if I have the answer key here. I do indeed. So the area of R, okay, the 0.54 and the 1.54. Okay, so these are the intervals. Then they came up with, so part A, no. What did we come up with part A? You said it was 2 point something, didn't you? Caleb, you said
Yeah, so that's why I kept getting a negative number, because
Yes.
I calculated part A using e to the 2x minus x squared instead of adding the -2.
Oh,
I was
yeah.
getting 1.7, and then when I was, or some 1.55, and then I ended with 1.72 once I subtracted it from the total, and then I was trying to subtract 2 from that, which kept giving me negative numbers. But now, yeah, it should have
Okay.
been, yeah, 0.51 or, yeah, 0.514.
Yeah, because this part A should be 0.514, and then this whole thing they came up with 2.061, and then you subtract off the 0.541, and you come up with 1.546.
Yeah, see, I got the area or the area of S and R. I did that, and then the area of R was apparently flawed. So
And I didn't look at it, so I was just taking Caleb at his word that it was 2 point something. All right. So does that make sense though? How we would find that? I mean, it was one of the tougher problems that I've seen. I mean, it did take a little bit of work to get that.
Yeah, if I hadn't messed up that, I would have been able to solve it.
Okay. I'm gonna have to check my answers before when I do this. Okay. So in this practice problem, it just says set up the definite integral that gives the area of the region bounded by the graph. Well, if you take a look here, first thing we want to do is we want to find our integral, our interval. So I'm going to go from -2 to, it looks like +2. And then my top function is y2, which is 2x plus 5, minus, and I always put parentheses there just to make sure I'm minusing that, x squared plus 2x plus 1. And, none of my answers look the same, but, you've got a minus in front of here, so I'm going to make that plus and make these all negatives here. So that's going to be negative x squared. 2 x's are going to cross off, plus 4. Yep, letter A is correct. Very good. Find the area of the region bounded by the equation. So sometimes they'll just give you equations. And I'm not going to do this one because this one, I can tell that you're just working without a calculator because that's why the answers are like that. So, all right, now, let's say we're integrating with respect to y, okay? When we're integrating with respect to x, it is just top function minus bottom function, right? So now, if I'm going to go on the y-axis, so let's say my function looks like this. Now my interval goes from top to bottom, okay? So my integral would be from C to D, and then my left function minus my right function, okay? So left minus right. So I've got f of y minus g of y. So anytime if your interval is from top to bottom, then we are doing. But remember, when we do this, it's got to be x equals. You got to change your equation so they're x equals. You can't have y is equal to, because that means it's on the x-axis. So let's see if I have an example here. Oh, no, I don't even have an example. Oh, that's not cool. All right. I guess the last thing that we have to do today, length of curves. What? The length of a curve? How do I find the length of a curve? You know how to find the length of curves. Okay, let me give you an example of a curve that you know what the answer is. Let's say I have x squared plus y squared is equal to 16, and I want to know the length of the curve from 0 to 4 on the top part. So this is a circle. It has a radius of 4. And I want to know what the length is from 0 to 4, just from here to here. I don't want this bottom part. Just from here to here. You guys know how to find the length of that curve? 2 pi? It just doesn't seem right. Circumference, isn't it pi r? No, pi r squared is area. Circumference is diameter times, isn't it diameter times? Oh, I got you because you already, okay, so your answer, okay. Oh, you're giving me the answer right away. All right, I was just trying to figure out the formula for it. Okay, because it's really circumference, right? When you're dealing with a circle, it's just circumference. And then you just plug it in, and this is 1/4 of a circle, so you just divide by 4. Okay, now, this is geometry. We're dealing with calculus. So in order to find the length of a curve in calculus, we have to do something a little bit tougher. The formula's not too bad. So here is the formula of a smooth curve. It says if a smooth curve begins at A and goes to C and ends at B, or starts at AC and ends at BD, then the arc length is given by 1 plus dy dx squared. Okay, and that's if it's A to B and C to D. Our integral or our intervals just change. So let's do an example here. It says find the length of the curve y is equal to x squared from 0 to 1. Okay, well, we know what that looks like, right? X squared looks like this, doesn't it? It's a parabola, and we're going from 0 to 1. Okay, so 0 to 1. I want to know what the length of this curve is. All right? So the formula, again, is just, let's go back one slide. The formula, again, is just the integral of 1 plus, well, it's just the radical, so we just got 1 plus the derivative squared. Right, so, oops. So if we take the derivative of x squared, we get 2x. So then we just plug that in here. So my integral is from 0 to 1, square root of 1 plus my integral squared, or my derivative squared, sorry about that. And then we have to, you cannot do these without a graphics calculator. I mean, you're not going to take the integral of this. Okay, so you've got to plug this into your calculator. So if you plug this in, 1.479 is the correct answer. Okay, so it's just the integral from A to B of the square root of 1 plus the derivative squared. That's all it is. I think I have another example. I'm not 100% sure. Okay, so here's another problem. It says find the arc length of the graph of the function y is equal to x to the third over 6 plus 1 over 2x over the interval 1 to 2. Whew, all right, first thing, integral. Second thing, square root of 1 plus the derivative squared. Well, I don't know what the derivative of this is, but I can figure it out. Okay, so that's going to be 3x to the 6 squared plus, and then 1 over 2x. I'm just going to write as, well, I almost messed that up. Almost brought the 2 to the top. All right, so that's going to be negative 1x to negative second. So this is going to be negative 1 over 2x squared, if I'm correct. And then we have to square that thing. All right, so I'm going to put that back in here. I'm just going to reduce this to x squared over 2 minus 1 over 2x squared. That is, I would not want to find that answer without a calculator. All right, but I'm looking at my answers and I'm like, oh my goodness, there's no way somebody did this by hand. So we're going to have to change all of our answers to decimals also. All right, what is my answer? What did you guys get? Integral from 1 to 2 of the square root of 1 plus, and then that big mess squared. Okay, what is our answer? Or what should it be close to? Because I'm just looking at my answers here. This is going to be like 2.0 something. This is going to be like 1.9 something. This is going to be like 2 into 17. That's going to be 1 point less than 5. It's going to be like 1.3. 12 goes in there like 3 or 4, almost, so 4.1, something like that. And this one is going to be like 3.9. So these aren't even close. So what did you get for a decimal answer when you plug that in? Nobody got it. Neither of you guys got it yet? 1.265? Okay, so I would bet you that 17 over 12 is like 1.265. I was just estimating when I was doing it. Let's see, I have a calculator here, so 17 divided by 12. Ooh, that's 1.4. All right. Henry, did you get an answer? I'm not gonna go with Caleb's answers anymore. You got that one wrong in the beginning. I mean, this is. I do have my calculator here, so I could plug it in. Let's see here. Let's see if I can still remember how to do an integral on my calculator. Ooh, I do. Oh, no, I don't. All right, Henry, did you get an answer, or should we just stick with the 1.265? And it really doesn't matter. I mean, but as long as you know how to set the formula up. 1.32? How can you get two different answers?
I'm struggling with knowing where to put parentheses when I'm putting it into my calculator.
Yeah, and that is especially you've got that square root, the 1 plus, and then you have parentheses, squared, parentheses. Yeah, that is one of the hardest parts about this type of problem is, plug it into your calculator, trying to make sure your parentheses are all in the right places. Yeah, I would agree with you that is probably a tough thing to do. All right. But finding the area of or the length of a curve is not that difficult. All right, any questions from you two? That is all I have for today. As I said, it's going to get tougher. Now, next week isn't tough. Next week we're dealing with volume. So we still have a couple more weeks that are basically, so 1.37, okay. So we'll go with letter C. That would be close. All right. So we still have a couple weeks that are review material, but then we start getting into vectors, polar coordinates, which gets a little bit more difficult. All right. You guys have a great week. And if you have any questions, yep. Awesome. Take it easy, guys. Bye.